Hello, everyone. Good morning, good afternoon, good evening to everyone who has joined us and who has been joining us across the globe. I welcome you all to the webinar, How to Fit Performance Testing Within a DevOps Environment. Or I could put it in a way that how to do continuous performance monitoring in DevOps. Now, we have been hearing a lot about DevOps through thought leaders, analysts, large enterprise, SMEs, how DevOps is bringing different teams together to work in cohesion, and how DevOps environment makes development lifecycle shorter with a greater amount of automation. Whereas performance testing, on the other hand, is complex and it takes time because it requires human action. So, how can a reliable and thorough performance test be executed in this fast-paced environment? And how performance test tools integrate in a DevOps ecosystem? Let's hear it out from our speakers for this webinar. So, our first speaker is Satish Kumar. Satish is a performance architect at Cigniti with 13 plus years of experience in delivering end-to-end performance testing and engineering activities. Now, he's a critical part of solutioning team that provides a digital transformation solution for enterprise level clients. Our second speaker for this webinar is Henrik Rext. Henrik is a performance engineer at Neotys with over 10 years of experience. His work includes large cloud testing on demand business such as trading apps, videos on demand, sports websites. Now he has in depth experience in insurance, car industry, retail, and energy sector. Now I'd like Satish to carry further from here. Satish, over to you.
Satish, there's a small issue. Yeah, there's an issue. It seems that nobody's get the audio. Everyone is on the chat is saying that is not hearing anything. Um, so I think there is a sound problem here.
Yes.
Hello, everyone. Hope I'm audible now. I would just wait for comments from people just to make sure I'm audible to everybody. If you hear me, could you just type it in the message box? Good, good. I see people responding. I believe now I'm audible. So let me just go back a slide to start what you've already covered. Sorry for the problem. Now I believe the audio it has been rectified. People are able to hear. So I am Satish, and thank you everybody for joining us today. So today we'll be talking about, to start with, a little bit about the pre-agile landscape, followed by agile and DevOps. What are the payoffs of DevOps, and what are the implementation challenges with DevOps? So when I say implementation challenges, from pursuit of performance engineering and testing, how do I actually align? How do I embed my performance engineering into the DevOps ecosystem? And the ideal framework, that would actually help me do this, help me conduct performance testing and engineering in this DevOps. This would be followed by the Neoload demo, which would be given by my co-speaker Henrik. So you have any questions, you can type it anytime, and we will try to take it at the end. So to start with, so when I talk about pre-agile landscape, Waterfall, that was one of the most popular models. So I thought I'll just pick that up to start talking about it. So we all knew about Waterfall. We all know how it works. Just on a very high level, all the phases of this development cycle, it used to be in a sequence, starting from planning to design, then develop, then deploy that on a smaller environments, followed by functional, non-functional, and UAT, and finally it goes to production. This was the general cycle that was followed in the waterfall model, and waterfall model it had some shortcomings. To name a few, I have put it here. The first thing was to get a working model out of this. Only at the later stages it was possible. So only after maybe testing, after that is done, end user would actually see something working, some workable model, workable item. So delivery time it used to be very high. The next thing is about the scope of the requirement. So once the requirements were frozen, it goes to development. If we had to do any editing to my scope, if I had to update my requirements, it was very difficult because I had to start this entire cycle again. So pushing new requirements, the scope, it was very difficult for me. The next thing which is very important for us, fixing the issues, fixing the bugs. So when we talk about bugs, it could be functional bugs, it could be non-functional bugs. So let us assume, for the sake, if we discover some issue with the architecture itself, with the design itself, addressing that issue, fixing that, it was very difficult, very time consuming, and very expensive. So these were some of the kind of shortcomings with the waterfall model. So this was followed by many other models, which Agile is one of them. Now, Agile, it addresses some of the shortcomings that we saw in waterfall model. So basically, how does an Agile work? Here, what happens, we have a requirement. So requirements are actually split into small chunks of work. Each chunk, we call it as a sprint backlog. We actually prioritize this backlog, pick up a chunk of work and start working on that. And we produce a workable model of this chunk. So this happens eventually, and chunk by chunk, it goes into a build, and it gives us a working model. So this is kind of an iterative process. So how has this helped? Now, because the requirements are broken into smaller pieces, for me editing a requirement, adding a new feature, it made it really easy. And the release frequency, because this is something continuous, the end user would see something very sooner, very quickly, compared to the waterfall model. Now we talk about DevOps. So basically DevOps, what it has done is it has actually widened the principles of Agile. So basically it made Agile more agile. So here the release frequencies, it was even more frequent. During this phase, we started seeing new breed of tools. We started talking about continuous integration, continuous deployment. So how did it help us? So basically what it did is, the sprint cycles, it basically automated most of them. So here what happens? It works something similar to Agile, but once a developer checks in a code, there would be a CI process kick-started, it would be triggered, and all the other things after CI, that is completely automated. So the CI itself would build the code, it would deploy it on a smaller environment, there would be a testing suite that is triggered, and feedback coming out of it. All this would happen automatically. Based on the feedback, the build would go to a repository and would be marked as a pass or a fail, or done or undone. So what are the payoffs of DevOps? What are the kind of advantages with DevOps? To start with, the delivery, it was very continuous. So, as we start working on the chunks, the workable model, it comes out very quickly. So all the time, a user would be able to see something coming out of it, even during early stages of the development, early stages of the life cycle. Coming to issues, this will actually help us enable issues a lot quicker than other models, a lot quicker than Waterfall or V model. Because we started working on the chunks, we can identify was there any error in that chunk. If yes, then go back, fix it quickly. Just add this bug fix or issue fix as my requirement to my backlog, sprint backlog. Start working on it. So yeah, here it enabled us to discover these issues, discover these bugs more quickly, hence allowing us to fix it more quickly, and it was easier to fix the bugs here. And the requirements, it allowed us to play around with the requirements, make it more flexible. So if there's some new feature that the end customer, end user wanted, he could always request for that, and that feature would again be added in our sprint backlog. That would be prioritized and worked on. So it gave us some flexibility to work around the requirements. And one of the things, it was always end user concentric. So as the end user, he would be seeing something coming out of it. He would be able to visualize what would the end system would look like. And, he can start giving the feedback that again goes back to the logs, sprint backlogs, and it would be worked upon. So finally, he wouldn't be surprised and he would get a system that he has visualized. So these are some of the payoffs of DevOps. So all this, it looks very good, it sounds very good, but when it comes to implementation, so especially the performance engineering part, so conventionally, when we talk about performance engineering testing, what used to happen, we used to go into the life cycle after the functional testing, have our steps ready in a couple of weeks, then we wanted to have that environment, a pre-prod environment, an environment that is compatible or comparable with the production, run our execution, run our suites, give a report. So typically this was 9 to 10 week cycle for us. So conventionally we have been doing the performance engineering in this way. But when it comes to DevOps, what are the challenges that I face? So these were some things, that were challenges, that were hurdles when we think about performance engineering in DevOps. First thing is the timelines. Now we understand the sprint. Ideally, a sprint cycle would last for 2 weeks, 3 weeks. A release cycle sometimes 3 weeks, 4 weeks. So everything is shorter. So how do I accommodate this 9-week, 10-week performance engineering cycle into this? That's one of the biggest challenge. The next thing is, what do I do? So what testing should I do? On which environments do I do? Do I have a pre-prod in this? Not really. So where do I do that? That was another question. Constant change. As we know, DevOps, there are constant changes to the code, constant changes to the requirements. How do I adapt to these changes? How do I actually work around the changes? Next thing is about the coverage. So how do I make sure all the critical portions of a sprint backlog and eventually of the applications is covered, and it is performance per se, it performs good. So these were all the questions. The last one, which is the most important one, how do I say I build this pass? How do I define my success criteria? How do I say, the build? How do I tick a green against the build? So all these questions we had when we started. So to talk more about this, I would like to tell you a bit about one of our clients. We had this a major airlines, one of our clients, and they had a big array of applications, and some of the applications were very critical for them, as most of the revenue were being generated by that applications. So there were around 20 applications in that space. And one day they came up with a crazy idea. They called it as digitalization. So what they basically wanted was, upgrade these 20 applications with new technologies, make it more peppy and get more business out of it. That was their idea. And to do this, they went with DevOps. They wanted all this development to, adapt the DevOps methodology and go by that. They came to us requesting to have some kind of a performance check over these. So again, when they came, we had all those questions of what, when, how do I scope my work, and how do I define a success criteria. We came up with a simple plan, a very simple plan, which looks like this. So now I divided my performance tests. I called it my, I designed my test starting from a subcomponent, a submodule, then a component, then a module. So I decided to do all this testing in my sprint cycles. So what it has to do is all these things, all these tests should be 100% automatable. So when there's a CI job running, all these tests should happen and should give a feedback. And this piece should be completely integrated with my CI component, which in this case was Jenkins. Then I would see a live feed out of this. So when a CI runs, I should be able to see some kind of a live feed that should help me make a decision. Also, the results should be integrated with the API. So I planned a module level, a page level, a component level testing at my sprint cycles, and I made this 100% automatable. That was the design. Coming to release cycles, this, once a build it goes out of the sprint, it was deployed on a bigger environment, something which is comparable to a production. We had all these upstream, downstream systems, so I'll be able to test my end-to-end flows, end-to-end user journeys. So yes, in this part, we planned an exhaustive performance testing, starting from load to a capacity planning to my spike test. So all these tests I planned in my release cycles. This was not completely automated. It required some manual intervention, but yeah, some portions it was automated. After release, it goes to production. So can I say my work is done after release cycle? Probably not. In this fast-paced development, there are chances there would be slippages, there would be some performance issues creeping to the production. And I had to make sure I discovered that before the end user. For that, we went ahead with API deployment. We implemented real user monitoring and synthetic monitoring. So this was the basic plan that we came up with. And this answered of what to do and when to do. Now, how did we actually implement this in our cycle? How did we actually plug it in my DevOps environment? The slide that we see, on the upper portion, you would see a typical sprint cycle where there's a sprint backlog that is developed from the requirements. It goes to the user stories, development, and a CI is triggered. Once this is done, a build would go to the release pipeline. So what did I do in parallel to this? So basically from the sprint backlog, I identified the features, I identified the features that could be automated. And based on the priority, I designed my scripts and I designed my scenario bucket. So from there, I took, okay, these scenarios should be, included in this sprint cycle. So in parallel to the development and building, I planned my scenario. I designed an approach. We started developing scripts, made it, completely automatable, and we integrated this to the CI. We embedded this to the CI. So once a CI is triggered, my performance suite that would be triggered, and this was integrated to a dashboard. We had an in-house built dashboard that would give us some metrics, give us some idea about how the build perform. So when I talk about the dashboard, what are the metrics? Do I have to have that exhaustive list of metrics, where I see each and every parameter and say this is doing well, this is not doing well? Would that work for me in sprint level? No. So we had to actually prioritize our parameters, prioritize our KPIs. So these KPIs, it should just tell me the quality trend of build over build. What parameters would do that? For that, we chose some of the most critical and important parameters, starting from response times, throughput, error rate, and the utilization. So my dashboard would only display these parameters. And actually, these parameters would be sufficient for me to assess a build. Say, was it better than the previous one, or was it not? So with this, we actually tick a build, saying it is done or it is undone. So once a build, it performed well over the previous one, or in par with that, it goes into my release pipeline. From there, it goes to a bigger environment. So where I had my end-to-end testing performed. So here I had all the integrations done. I had my upstream, downstream systems running, or maybe simulated or stub. So I could plan all my testing here, the end-to-end testing, exhaustive testing. So here it was more like a conventional performance engineering, what we've been doing. So we had done all our tests here. Again, a live feedback from this, and a go decision would be taken at this cycle. Once it goes live, we had the APM, which again gives us the feedback. So do I stop my work there? Again, no. I'll have to pick the feedback from my APM, and I should use this to better my approach, to better my performance testing strategy. So there would be a constant feedback or inputs going from the APM into my test requirements, again back to the sprint level. And I would constantly keep trying to improve my framework in the sprint level and the release level. So eventually what had happened? Eventually, yeah, we were able to come up with a build that was, which had a good quality, top-notch quality. So yeah, this helped us. It worked for us. So when we started developing this framework, so what we wanted our framework to have. So if a framework has to, support all these things, how should my framework look? What capabilities that should have? So these were some of the capabilities, or define my ideal framework, without which I couldn't have implemented a performance engineering cycle in the DevOps. To start with, it was the SLAs. The tool, it should allow me to set the SLAs. It should define a build is a success or a failure. The test executions, it should be 100% automatable. So I have my execution suite, which should be integrated to CI and triggered along with the CI. Give a feedback, which is the next point. So this should have the capability to integrate with my, the CI landscape, my reporting tools. And it should give me some good reports that would help the stakeholders take a decision. Finally, it should have the capability to integrate with the APM tools. So for this instance, for this client, we had used App Dynamics. So my suite, it had some capability to integrate with the App Dynamics that will help us quickly get to the bottom of our issue, resolve it. So these were basically the things which we thought is necessary to in our framework to actually put it into the DevOps. So what did we learn from this? I mean, for us, what we experienced. So what we deduced from our operations in this. Basically, these were the things that worked for us. So on the sprint level, we had planned to test a feature as soon as possible, and we made sure we're not over testing or over measuring. For example, if I have to do a 3,000 user test in my sprint level, the results it will be of no value. They being smaller systems, it will not actually not help me take a decision, not help me on that. So I limited my test only to the things that help me take a decision. And quality trend. So the most important thing for us during the sprint cycle was the quality trend. I should be able to assess the quality trend of a build over build. So if I go to discrete metrics like TPS, I just concentrate on one metrics, that will not help me. So for me, a trend was very important. So in sprint level, these were the things were implemented which worked for us. Going to the release level, yeah, we had all the exhaustive testing planned and we made sure we are mimicking the real world conditions. We had all the users. And when we do a test, I made sure we had some kind of an analytics mechanism that would actually help me resolve the issues, help me better the environment, better the architecture, and finally help to do a capacity planning. So all these were done in release level. Production, as I was telling you, we need a continuous feedback from the production. So it could be end user monitoring, real user monitoring. There was a constant feedback that was coming from the production that helped me catch a bug before the end user and also help me, mature my process, improve my performance engineering process in this entire cycle. With this, I'll pass on the control. I'll request Henrik to start his demo.
Yes, thanks, Satish. Thanks for this presentation. So I'm just up first of all, so I'm going to say hi to everyone. Thanks to be here. So here the idea is to make this demonstration align what Satish just presented. So I'm going to do something very, let's hope that everything works fine. So up, let me check. I'm going to try to, so I'm gonna share my screen at the moment. So I'm just gonna see if someone can just confirm that he's seeing my screen. That will be just perfect. So here, if you're familiar with the movie Inceptions, I guess you can see Inceptions right from your screen. So just can someone confirm that you're seeing my screen, and then I will start the demonstration straightforward. So nobody's answering. Yes, perfect. Thank you. So here, the idea of this demonstration is just to highlight what has been presented so far by Satish. So with an example, so it's not going to be the use case that Satish just shared a few minutes ago, but it's going to be just on a small application, very simple one, but at least it will highlight a representative pipeline. So here, just to mention pipeline, use the pipeline. So pipeline, everyone using DevOps world. So pipeline is basically something that transport not water, but we're going to transport your code, build that code into application, and then we're going to transport that directly to the production environment. So here in this pipeline, I'm using several a tool chain with several products here. So that the mix of open source and open source product and very popular frameworks of the market. So we're using in this tool chain, so as a source control, it's going to be Git. So the source code will be stored there. The application I'm going to show you soon, it's AngularJS, so there's Java code based on the back end, and so all the code will be built through Maven to build the application. And once we have built the application, we need to do some code analysis to check that the quality of the code is efficient enough that for this release. And then we are going to deploy the application in several environments. So to deploy that, in order to make it simpler in terms of sizing of the environment required, we're going to use Docker. And we are deploying that in 3 different environments in parallel. And I will explain it why we do that. Because sometimes when you automate your tests and you detect regressions, it's always fair enough and interesting to get a feedback of the test results on 2 different environments to make sure that it's not related to the deployment, to the environment, to the network, but it's just related to your code in your application. Next step, it's going to be tool deployment. So here we're using an APM. So we're deploying the agent with this process here in this environment, and we do also deploying the load generator. So the load generator, to remind for those who's not aware, in the load testing solutions, you need a load generator component, and that component will be responsible of generating the load against your application. So this, in our example, because Neoload is compatible with container-based components, we're going to deploy our load testing architecture based on Docker. And then here, from that step here, we are starting the testing, the validation steps. So first with the more, let's say, the gray box testing, so the technical tests. So Satish mentioned that he was testing the subcomponents, the components, and this is what we're going to do here. So we're going to do these component tests based on the API, because the application is based mainly with APIs, and I'm going to explain the architecture later on. Then we do some sanity check to make things sure that everything is there. And once we got the green lights on that step, we can move on to the testing phase. So here in our case, we're using Selenium has an automation functional testing solution to validate the overall functional behavior of the application. And then we're using YSlow here in our example to validate that also the web performance, the rendering piece is done smoothly on the client side. And once everything is done perfectly, we need to validate, in any case, the end-to-end testing. And then if this is fine, we go to deploy that in production. Why do we do the end-to-end testing? Simply because we need to make sure that the user experience, the architecture, when we assemble all those components together, they will respond properly. So here, like you can see here, Jenkins will be will orchestrate everything. So he will be our chef of this pipeline. All right, so let's have a look at the application. So here, this is the applications, a really very simple application where you can typically just post a weather incident around the globe. So here at the moment, we're looking at the 1.0, which is in production. So here you can see that most of the people can report weather incidents from the browser. It's a responsive design application, so you can do that by mobile device or by browser. But here mainly the comments or the report that you're sending to the app is mainly a text format. So that's a very simple one. And what's going to happen here, we have an existing pipeline running with Jenkins. What happens is we are coming with a new release. I'm going to just disable the production environment just to have a look at the dev environment here, which has the new feature. And this is going to be what we are going to do. We're going to maintain that pipeline to make sure that we are able to go with this new release in production. So here the difference is we're able to push a picture. So it's a minor release, but still, it means that potentially in our pipeline, something's going to break down. or automation piece will not work anymore. So how we're going to maintain that? So let's have a look at how we can do that. So first, let's have a look at Jenkins. So here, this is my Jenkins. As you can see here in Jenkins, I have 3 jobs. So one main build, which is a group with scripts. And then we have 2 different jobs because Neoloads Jenkins plugins works with jobs. So I'm just going to show you this similar UI of Jenkins, but with Blue Ocean. It's just a web UI layer on the top of Jenkins, so nothing to change related to Jenkins. It's just that it's nicer look and feel. So you can see it's exactly same process that I just explained. So let's have a look at first of all, I would like to show you the results that you can have in Jenkins. Because the idea here with DevOps, we need to collaborate. We need to make sure that our testing results, our testing data is accessible for everyone. So either pure developers, either manager, whatever it is. So here you can see in that dashboards, we are displaying here, we're trending a couple of metrics. So here the errors, so here you can see here it's the build number, and you can see the trend on the errors, response times, but also although project has different KPIs. So Satish explained that he was looking at the throughput, the CPU, and so on. So here in my example, I am decided to trend 2 different KPI related to my project. It's going to be the API response times and the MySQL response times. So trending is really, really important here because we're not going to analyze everything that we launched by our load testing product here anymore because it's going to cost a lot. We want to trend and figure out when we got a regression. So if we have a regression, for example, let's say that build number 15, we were higher expected. So we can have a look at one of the builds here. I can click on build 25, for example, have a look at the G-Unit report, and also have a look at part of the report that's been generated and stored in Jenkins here. So you can also have access to that. So that's typically what you're getting out from Jenkins or Bamboo or whatever it is, basically your build server, your CI/CD, sorry. So now let's have a look at what we have in Neoload. So here I'm opening Neoload for those not aware of Neoload. So Neoload is a load testing solution. So that's allows you to deliver load testing in a really efficient way, in a productive way, and also that fits very well in a DevOps environment. So here, first thing I'm going to do here, I didn't mention that, but because we have a different team here within our project and located on different areas, we need to collaborate. So that's why I'm storing my project into a source control. So first thing I'm going to do, I'm going to check out my project to get the exact same release of my project that is currently used by my CI/CD server, so Jenkins. So once we're going to get back the project locally, I'm going to explain a few things. So this project has mostly everything: the component piece, the SQL piece, and also the end-to-end piece. So as you can see here, so this is the Neoloads UI. So here you have the design, you have the runtime, and you have the results. So it's exactly the same, the 3 main steps of a load testing project or process. And here we're going to look at the design aspects. In the design here, I can see that.
Sorry to interrupt you.
Yes.
This is Satish here. Actually, we just see this DevOps toolchain page. I do not see the new load. I think the screen is not refreshed.
So let me try to relaunch the sharing.
Mm-hmm.
All right. Do you see my screen now? Do you see Neoload?
Yes, we see it now.
All right. Let me know if something is not displayed, so to avoid speaking to myself. Sure. So here, like I mentioned, this project has the technical tests, but also the end-to-end tests. And like Satish mentioned, that first you take the user stories, you figure out what's you're gonna add in your automation or your testing steps. And in my case, the main page is doing the same SQL query on and on and on. So I'm going to make sure that my database structure and my database is responding properly, because I know for sure if it's coming slowed down, it's going to have an impact on my user. So I'm going to test that on a technical way by sending queries to the database. So that's the first component test that I do from a database perspective. The second one, because here it's using a lot of API in the background. So here I'm testing one of the API, it's the post API, and I'm passing some variables to randomize my calls. So that's typically, so here I got a couple of variables where I can randomize the data sets of my API tests. So that's typically what we're doing in a technical tests by sending queries to database and sending API calls. And this is automated by Jenkins. So now let's have a look at the second step. The second step is the end-to-end. So here it's mainly from the UI, from a traditional web interface. I record. Here you can see I have a couple of transactions, homepage, posts, submit, map. Here the idea of that scenario, it's been already correlated. So I want to show you how to design here. You can see here, for those who are familiar with Neoload, you can see that we already have Neoload variables available in this JSON call, for example. So now, I told you that we have a new release with a 1.02, and this script here, post, is pointing to the old release, the 1.0. How do I update that scenario? Simple. I'm going to take advantage of the work done by my colleagues. So in my case, my colleagues is building Selenium scenarios. So let's have a look at the Selenium scenarios. So here it's a Selenium script that has been built. It's using, in fact, Chrome. And what I just did here, or what I just asked my colleagues, is to use Neoload's Selenium wrapper. And Neoload's Selenium wrapper has two modes, design and end user experience. Design, the idea is to convert these Selenium scripts into Neoload technology. User experience is take advantage of Selenium to report back the user experience. And here, this wrapper has no incident, has no impact on the automation of your automation team. So they can use the wrapper. It will be only wake up and do things from the moment you pass the proper argument to your script. So here, the only line of code I'm adding here is these P's here. Driver, new Neoload driver. Here I'm just passing to that our driver Neoload, the traditional driver that the tester has defined. Here it's a Chrome driver. So I'm passing that to our
Henrik,
wrapper.
sorry again.
Yes.
It's frozen again. The screen is not being refreshed.
So let me restart sharing that up. All right, do you see my screen now?
We do. Yes, we do now.
Okay, thank you. So here I highlighted one line, which is the definition of the Chrome driver. And in fact, this driver is being passed to define our Neoload drivers. That's the only line of code that's been added to be able to take advantage of our Neoload wrapper. The other thing here, if you look at, for those who's familiar with Selenium, we have introduced a new method called start transaction, which doesn't exist, in fact, in Selenium, because Selenium doesn't care of transactions. We do, but not Selenium. So this method is silent, which means doesn't do anything once you run it in a normal Selenium fashion way. But if you use it with Neoloads, it's going to pass the transaction to us. So now let's execute this Selenium scripts. So I'm going to close down. What I'm going to just show you here, I have already a bat file that I'm going to run with the automation. It's just basically calling my Selenium scripts that has been pre-built, so this in the jar files. And this piece here, this is where I'm passing the mode of my wrapper. I'm passing design, so which means it's going to convert this script. And this script, like I said, has been updated, which means he already has the features related to the 102. So I'm going to duplicate to. I don't know what's going on. Okay, so that's the demo effect, I guess. Yes, that's the demo effect. So let me open that. Okay. I don't see the script running. Gosh. Never mind. So it means here the traditional normally, if we didn't have the demo effect, we should see this Chrome executing in the background, and it would basically update automatically the neoload scenario. So I don't know why it's not running. I'm gonna last try. Okay, never mind, it doesn't work. Or I'm gonna do this command line here. Okay. Okay, never mind. So it doesn't work. That's the beauty of a demonstration. So normally it's supposed to run the Selenium script, and after the execution, he automatically updates the scenario, because we apply what we call the automation maintenance scenario, where it's compare the new traffic that has been recorded with the existing design, and all your variables, everything is maintained. We just add in the differences. So that's the idea by this wrapper, is to reduce the maintenance times and do it automatically. So here I was not able to run this maintenance. I'm gonna still run the build, so it should fail in certain stage, because I'm still having some testing assets pointing to the 1.1.0, and our application is in 1.2. But what my concern here is to show you one other things is when it comes to running tests through Jenkins, it's good, you're going to automate everything, but it could be quite frustrating. Why? Simply because you're going to launch a test that potentially going to run during 10, 20, 25 minutes. If developers make an update on the homepage or the login, which is one of the first step of our tests, he won't be able to get a feedback until the end of the tests, because all the trending dashboards that I showed you in Jenkins are generated after the tests. That means I have to wait very gently until the end of the test to get a feedback. And that could be quite frustrating. And this is the reason why we have introduced our new platform called Neoload Web. So here, I'm going to log in Neoload Web here. And this is my sessions. And once we arrive to the step where Neoload is involved here, so in our case, it's going to be the API testing here. So it's going to start the build 26 here, as you can see here in the output of the task. And if I go back to Neoload Web, in a few seconds, we will see automatically the API testing that has been streamed to Neoload Web, which means I will be able to look at the results directly from my browser, from a tablet, from a phone, or if I have good eyes, and do the live analysis and live trending and live comparison. So let me check where it is.
Hey, Henrik, I think again you'll have to reshare your screen again. Things are frozen.
Okay. Sorry for those technical issues. That's quite frustrating for me and for you guys. So as you can see here, this is Neoload Web, and you can see here automatically, I didn't do anything. The data that Jenkins is starting a test, I can see the test results here in live. So I can see the user load, the hit per second, exactly like we used to do in the traditional Neoload client that we have here. But what I'm more interested in here, I'm going to have a look at the SLA as well in live, but more interested is comparing. I want to make sure that the response times of my application is good enough for the commit made by the developers doesn't introduce any regression. So what I'm gonna do, I'm gonna just drag and drop the API call here, and you can see here it's coming from the build 26, so the live test running in, and I'm gonna compare to the other tests, this one, which means now with Neotys Web, I'm able to do live comparison, and I'm able to detect directly without waiting 25 minutes or less, or 10 minutes, whatever the duration of the test you have been introduced in Jenkins. I can compare it in live here directly from a graph. So I decided to do it with an API call, but if I wanted, I can do it with the monitoring. I could trend CPU, memory, whatever it is. And then this is more comparison approach. And if I have several people connected to do that test session, I could share my graphs, which means everyone can see things. We can do the cross analysis together. The other piece is trending. So here, this is the trend graph provided by Neotys Web. And as well, I don't have to wait until Jenkins has finished. I'm able to see directly in live the trending reports. So my developers is not frustrating anymore because he could commit, trigger a test in Jenkins, and go directly to our dashboards and see in live if his code has impacted the application's behavior in terms of performance, of course. So that's typically what I wanted to highlight today. I hope you at least saw most of the things, even if you have we were facing some issues with the screen sharing thing technology here, but this is typically what I was seeing. So what I'm going to do, I'm going to close down this the screen sharing. If you have any questions, I will be more than happy to answer to your questions. Hello.
Thanks, Henrik. Yes, there were some technical glitches, but I believe people were able to get the message what you were trying to show. Yes, thank you for that. So if anybody has questions, yeah, we can take the questions now. So I see some questions on Neoload. Henrik, would you be able to take that?
Yes, so I think it's except Jenkins does Neotys support other continuous integration server. So yes, of course, the answer is yes, we support. So we have plugins available in the community for Bamboo, so you can have access to that for the Bamboo users. But we also have it from Team City as well, and we are going to soon provide plugins for Xebia Labs, which is a very Excel release, which is also a way to define a pipeline. But even if we don't have any plugins, just for your information, we have command line options in our product, and we also have a couple of APIs and on tasks. So which means even if we don't have any plugins, triggering the tests and automating the tests is possible even if there is no plugins, just by using the command line and the on tasks.
Thank you. So I see another question by Praveen. He's asking, would everyone follow the same standards for DevOps? So basically DevOps, the principles would be the same, but how that is designed, how the pipeline is designed would be dependent on the application that is being developed, the size of the application, and the tools that are being used for buying CI and CD.
I think there's another questions for Neoload, I guess. Do you have any other integrations with automation testing solutions? So here, during the demonstration, I tried to highlight the integration we have with Jenkins. We had a small demo effect. Sorry for that, but if you need more details on Selenium, I'll be more than happy to answer to those questions or showcase that later on. But to answer your questions, we have lots of integrations. So we have RunnerX, we have Tosca, Tricentis. We have, for those who's familiar with Inflectra, we integrate with Superior Team, which is test management solutions, and also Rapiz. We also have a couple of other integration more on the mobile testing side, which is, in fact, to be honest, all the platform compatible with Appium. So there will be a Perfecto, of course, Bitbar, Cobiton, and many others. So there's a lot of integrations, and we have all the stack on top of our product. So SDK, APIs that will allow you or to build your own integration. So creating integration is possible. We already have all the technical layers to do that.
I see other question. She was asking if load runner can that integrate with DevOps? So the answer is yes. So any tool that exposes its API that has a capability to run the executions automatically, yeah, that can be integrated to DevOps.
I think one of the important steps. I'm just gonna just mention that any tools, of course, can be used for DevOps for sure. There is no problem. You have to figure out if the tool fits well with your project, technology-wise, and process-wise. If you have a short testing cycles where you need to maintain, build your scenarios, you need to figure out, make sure that the product that you will use for this pipeline or this delivery model is aligned and will be productive enough. That's the idea. So I think there is a question here. Any useful load generator tools that test latency of streaming data? Async, background tests, pipelines, basically tools which can load test systems different from request response services. So Nabil, to answer your questions, there are many load testing solutions that has the capabilities. So NeoLoad is one of them. I think Load Runner has the same idea. It's a product. It's a matter of having the protocol. So if the load testing solution has your expected protocol, then you will be able to do that. So just to answer from NeoLoad perspective, we have already support for streaming data technologies, such as RTMP, HTML5, service size events. We have WebSockets. We have many different push technologies framework. We also have a partnership with Push Technologies that deliver the diffusion framework as well. So it's not a request response approach. It's different. But also, if we don't support it, we have lots of SDK, like I mentioned, that will allow you to add or code that missing protocol to allow you to test and include this within the pipeline.
Yeah, I think we are going to wait for 1 more minute. If you guys have any questions, we'll take it up. And, okay, in case you have any questions, what I'm going to do is I'm going to write down my email ID, and you can email me your questions. We can take it up from there. All right, now you can write me your questions to marketing@cigniti.com. And it was a pleasure having you, Satish and Henrik. And yeah, I think we're going to wrap it up now. Thank you everyone for joining us. Yeah, bye bye.
Thanks to be here. Have a pleasant afternoon and a pleasant end of the day.